We've all looked up at the night sky and seen stars. Those twinkling lights have always fascinated us, sparking our curiosity and imagination. But did you know that out there, among those stars, are giant rocks floating around? These aren't just any rocks, they are asteroids, remnants from the early solar system. These are asteroids. And they're more than just space debris. They are ancient travelers carrying secrets from the dawn of our solar system. They are treasure chests full of valuable resources. Imagine finding gold, platinum and other precious metals just floating in space. For years we've dreamed of going to space, of exploring new worlds. The idea of venturing beyond our planet has always been a part of human ambition. Now we're on the verge of something even more ambitious, mining asteroids. This could revolutionize how we think about resources and space exploration. That's right, getting resources from space rocks. Imagine robotic arms and advanced machinery extracting these precious materials. This isn't science fiction anymore. The technology to make this possible is being developed as we speak. With advances in technology, asteroid mining is becoming a reality. Companies and space agencies are investing in this groundbreaking endeavor. It's a chance to find new sources of materials that are rare on Earth. These materials could be used in everything from electronics to renewable energy. Plus, it could be the key to expanding our presence in space. Establishing a foothold on asteroids could pave the way for future space colonies. So, buckle up, space fans. The future of space exploration is here, and it's more exciting than ever. We're about to dive into the exciting world of asteroid mining. Get ready to witness history in the making as we unlock the secrets of these celestial treasure troves.
Why go through the trouble of mining asteroids? Well, imagine a gold rush, but instead of gold, it's platinum, gold's more valuable and useful cousin. Asteroids are loaded with it. We're talking about metals like platinum, iridium, and palladium. These are used in everything from electronics to medicine, and they're not exactly plentiful on Earth. Then there's the water. Yes, water in space. It's not for drinking, at least not directly. This water can be broken down into hydrogen and oxygen, which are rocket fuel. Imagine having gas stations in space. The potential economic benefits are astronomical, pun intended. By some estimates, the resources in the asteroid belt are worth more than all the money on Earth. That's a lot of zeros.
We just talked about the economic reasons for asteroid mining. But there's a bigger picture here, one that goes beyond just making money. See, Earth's resources are finite. We're using them up at an alarming rate. Population growth, industrialization, it all takes a toll. Asteroid mining offers a solution, a way to supplement what we have. Imagine a future where we're not limited by Earth's resources. We could build things in space, create new industries, and maybe even solve some of our environmental problems here at home. This isn't about abandoning Earth. It's about ensuring a sustainable future for humanity, both on our home planet and beyond.
Okay, so we know asteroids are valuable, but how do we actually get our hands on these resources? It's not like we can just fly up there with a pickaxe and start digging. First, we need to identify the right asteroids. Not all are created equal. Some are closer, some are richer in certain materials. It's all about finding the best targets. Then comes the extraction. There are several ideas on the table, from scooping up surface material to literally capturing and mining an entire asteroid. Once we have the raw materials, we need to process them. This could involve separating metals from rock or extracting water. It's a complex process made even more challenging by the harsh environment of space. Section 5. Robots in space, the unsung heroes of asteroid mining. Space is a dangerous place. Radiation, extreme temperatures, no oxygen. It's not exactly hospitable to humans. That's where robots come in. They'll be our eyes, hands, and tools in space. Autonomous robots controlled remotely from Earth will be doing the heavy lifting, literally. We're talking about robots that can drill, excavate, and even process materials. Think Wall-E, but with a mining degree. The development of such advanced robots is crucial for the success of asteroid mining. This isn't just about keeping humans safe. Robots can work around the clock. They don't need sleep or food, and they're not fazed by the harsh conditions of space. They're the ideal space miners.
Section 6. Space Law. It's not just science fiction anymore. As humanity reaches further into the cosmos, the need for a comprehensive legal framework becomes increasingly urgent. Here on Earth, we have laws about who owns what, especially when it comes to valuable resources. But what about space? Who owns the asteroids? The question isn't just theoretical anymore. It's becoming a pressing issue as technology advances. The Outer Space Treaty, signed in 1967, states that no nation can claim sovereignty over celestial bodies. This treaty was a monumental step in ensuring that space remains a domain for peaceful exploration. However, it doesn't explicitly prohibit the use of space resources. This ambiguity has opened the door for various interpretations and potential conflicts. This has led to some debate and interpretation. Legal scholars, policymakers, and space entrepreneurs are all weighing in on what the future of space law should look like. Some argue that the treaty implies a common heritage of mankind approach, suggesting that space resources should benefit all of humanity, while others believe in a finders-keepers principle. This perspective holds that those who invest in the technology and effort to reach and mine asteroids should have the rights to the resources they extract. As asteroid mining becomes more realistic, we need clear legal guidelines to avoid conflict and ensure responsible resource utilization. These guidelines will be crucial in preventing disputes and fostering international cooperation. After all, we don't want to start a space war over who gets to mine which asteroid. The stakes are high, and the decisions we make now will shape the future of space exploration and resource management for generations to come.
Section 7. Space junk and other cosmic concerns. The environmental impact. Mining, even on Earth, has environmental consequences, so it's only natural to wonder about the impact of asteroid mining on the space environment. One concern is space debris. Mining operations could create a lot of it, from shattered rock to discarded equipment. This debris could pose a hazard to satellites and even future space missions. There's also the question of disrupting the natural environment of celestial bodies. Should we be altering asteroids for our own gain? What are the long-term consequences? These are important ethical and practical questions that need to be addressed. We need to ensure that asteroid mining is done sustainably without causing undue harm to the space environment. Section 8. Who owns the stars? Ethical considerations in space mining. The potential benefits of asteroid mining are vast, offering access to precious metals and minerals that are rare on Earth. But we can't ignore the ethical dilemmas it raises, which are as vast as space itself. For instance, if a few companies or countries control access to these resources, it could lead to monopolies in space. What does that mean for everyone else? Will the benefits of space mining be shared, or will they be hoarded by a select few? Will it exacerbate existing inequalities on Earth, creating a wider gap between the rich and the poor? Could it lead to the creation of a new space elite, living in luxury while others struggle? Or will it be an opportunity to lift humanity as a whole, providing resources that benefit everyone? There's also the question of how we manage these resources. Do we have the right frameworks in place to ensure fair distribution? Do we prioritize immediate profits or long-term sustainability? The environmental impact of space mining must also be considered. Do we use them to benefit everyone on Earth, ensuring that the wealth generated is shared equitably? Or do we allow a select few to control these resources, potentially leading to new forms of inequality? These are complex questions with no easy answers. They require careful consideration and global cooperation. But they are questions we must ask ourselves as we venture further into the cosmos. As we begin to exploit the riches of space, we must ensure that our actions are guided by ethical principles. Only then can we hope to create a future where the benefits of space mining are shared by all of humanity.
Section 9, A New Space Age, the potential of asteroid mining. Despite the challenges, the potential of asteroid mining is undeniable. It could usher in a new era of space exploration and development.
one where humanity becomes a truly spacefaring civilization. Imagine a future where we have permanent settlements on the Moon and Mars, powered and supplied by resources mined from asteroids. Imagine giant space stations constructed using materials harvested from space. Asteroid mining could be the key to unlocking these possibilities, providing us with the resources and infrastructure needed to expand our footprint in the cosmos. It's a future that captures the imagination, a future where the sky is no longer the limit, but rather the starting point for human ambition and ingenuity.
Section 10. To Infinity and Beyond. The future of asteroid mining. The future of asteroid mining is full of possibilities, but it's not without its uncertainties. Technological hurdles remain, legal frameworks need to be established, and ethical questions need to be answered. However, the potential rewards are too great to ignore. The resources locked away in asteroids could transform our world, providing us with the materials we need to solve some of our most pressing problems and create a more sustainable future. It's a journey that will require collaboration, innovation, and a willingness to push the boundaries of what's possible. But if we succeed, the stars themselves may not be the limit.